So this one's kind of neat. It's number 5 in the most important series of essays and articles that I've written recently because it reinforces convention, especially general relativity. Brookhaven Revisited, dated October 11th. So there's an image of data taken from StarDTAC and Brookhaven National Lab some years ago, comparing vertex populations of matter and antimatter. Matter and antimatter. Except, as you notice, in the upper part of the image, there's a discrepancy. There's a deficiency of tritium. And why? Why would that be like that? The Brookhaven data, again, anti-nuclei production. The challenge here is to accurately estimate the hydrogen-3 or tritium population. Previously, I spent hours conservatively and less than that counting. Now we have a new estimate, 0.2027656 squared, which is approximately equal to 0.041. A possible better estimate of rate factor between antimatter and matter previously was estimated at 1/16. The question here is the population of antitritium over tritium approximately equal to 0.041? Here I interject the statement from Wikipedia that the free neutron mean lifetime is what? Approximately 880 seconds. And then make a prediction based on 0.041. Approximately 36 seconds and 25 seconds, new estimates for free antineutron mean lifetime and half-life if. The question answers truly. Let's investigate. So this is from an old archive, an archived image from StarDTAC at Brookhaven National Lab of antiparticles and particles produced at the vertex populations. Well, anyways, it's a long story. You have to look into it. I said count these, which is what? Tritium. So we can compare why, or ask the question, why the difference between antitritium and tritium? So it's a zoom in of that section, the bottom right. A rectangular section toward the left, tilted counterclockwise 30 degrees, appears to be 3 times saturated. I mean, there's a lot of data points. This would seem to fill the entire rectangle with uniform dots if unsaturated. My estimate would be 20 by 35. In that case, about 700 instances, if you spread it out. Now, we count the easy section, antitritium. If you look at the dots very carefully, which appear to possess a count of maximum 14. Which implies what? 13 plus or minus 1/700. Since most of the uncertainty resides in the latter, in this framing, the latter estimate, which implies that what? 0.019 plus or minus 0.00143, which implies 0.02, which is on the low side. Follow with me, just follow with me. 14/350 equals 0.04. It assumes a twice saturated tritium count and conservative estimate for the latter, meaning what? The tritium count. What? Antitritium. 14/1.75 is equal to 0.08. Assumes a single saturated tritium count, and conservative estimate for what? For the antitritium, which implies 0.04 plus or minus 0.02 is reasonable. It's reasonable. And at antitritium over tritium, the populations count from this laboratory results about this investigation of vertex populations of creating antimatter is approximately 0.04 plus or minus 0.02, which is approximately equal to 0.041, which implies we can accept the hypothesis. We can. That the new estimate for anti-neutrons, mean lifetime and half-life are 36.2 seconds and 25.1 seconds, respectively.